I'll circulate a Google form for forming the groups. But now will Sankadeep explain them the virtual lab?
Yeah, that we can explain. That is not a problem. So okay,
so group, what do you think is a good way? What I was thinking is that I'll circulate a Google form and let them form a group there.
Or we can do one thing. Are you ready with the group? So you can answer. I think you people are not answering.
Yeah, maybe they should answer.
Are you ready with the groups?
So some of us are ready and some of us are still in the formulation phase.
I think let us give them a little bit of time. Can you put up the form right now? Will it
The
take
Google form? Yeah, I can put up right now.
So you can put it up right now. Let them form the groups now. Let us give them half an hour to do that. I think
okay, just one more thing is that should we keep the same group for theory and lab?
For theory, no. Let us not link up that way.
Okay.
Let us not link up that way because there is one more reason. There may I mean a few students may differ also in theory and lab.
Okay. All right.
Yeah. So let us not link the two.
Excuse me, sir.
Yeah.
Sir, I think Google Docs would be better than Forms.
You want a Google Doc, like a Google Sheet, you mean?
Yes, sir. I think that would be better.
So why don't you make
sir,
one
that
and
would be
circulate? Can you make one and circulate, whatever is convenient for you? Can any of you make it and circulate, or do you want me to make it?
Sir, we can make it.
Okay, then make it right now. Make it right now and let us, and you can share the link with us. So we'll just see what.
You post the link in the chat box. You post the link in the chat box so that everybody can join. Also, I'll mail the link in the ERP so that all the registered students get it.
So, have you given us the link? Not yet.
Sir, just a minute.
Okay. So you can.
So I think you have to give access permission. Otherwise.
No, I think no. Member 4. All right. Okay. Yeah. So, yeah, up to 4 people per group.
Sir, some of our team's request is still pending, so we are not able to see the chat because we are not a member of the team, MS Teams group.
What is the issue? I mean, what is the issue with them? Do you know?
So,
No,
sir, we have.
I have approved all the requests. I have no pending request. You please check. I have approved all requests. Just check once more or re-log in.
Okay, sir.
Re-log in again. I have also mailed it in ERP.
Sir, we cannot change the seat right now because of heavy traffic in that particular seat.
You just wait a little bit.
It will settle down in a few minutes. Well, many people are trying to type, that's why. Don't bother about the group number. You can remove that column. Group E. That column E you can remove. Group numbers will come automatically. You just don't bother about the group numbers. Just form the groups.
I mean, there are some blank rows. We'll remove them later.
Yeah. You can remove them also. But those will not matter.
No, let us wait. Let us wait.
I think row 16, there might be a duplication of name. Just check. Row 16, there seems to be a duplication of a name. Wasif's name has come twice. Or I don't know whether my thing is there. Okay.
Sir, can you refresh it? I removed
Yeah,
one.
yeah, okay, it has been refreshed. Row 44, someone has given just the roll number. Don't leave, just give your name and roll number both. That will be better. Give both your name and roll number. Don't give.
No, so all of you have already given the name. Everybody, please write a comma separated roll number after your name. Write a comma separated roll number.
Excuse me, sir.
Yeah.
No, it's okay.
Sir, someone is
put.
raising my name again and again.
Don't do that, please. Yeah. Just put your name where it is okay. Yeah, no, it's okay the way you put your roll number. You can put your roll
Yeah,
number.
and those who have finished it can close that tab. So the load will be less. Those who have already put it.
No, it's not
Yeah.
necessary to close. So long as they don't edit, it's fine.
Okay.
Yeah, it's okay. I mean, if they just leave it open, it doesn't matter. Pronil Day, I think you need to put in your roll number. So those of you who haven't put in your roll numbers, just do that. I mean, name and roll number both. Yeah, avoid comma because sometimes we save this in a comma separated form. So avoid commas. Just put the roll numbers in brackets. Don't put any comma anywhere. Put your roll number in brackets and don't use any comma. Row 26 seems to have only one member. You can join some other group. Let there be at least 3 people in each group. Let there be at least 3 people in each group. You can do a bit of consolidation among yourselves so that we don't have too many small groups. So try to keep the number between 3 and 4. So 53 and 59, maybe you can work together. So I think most of you have entered your names and roll numbers. So maybe you can do a bit of consolidation, discussing among yourselves. Okay, alright. So I think this seems to be nearly done. So just the blank rows can be dropped. This seems to be fair.
So CRM only one group
Hmm.
is modulo 4. It is 1, the total number. So
Gaurav,
can one student join a group?
there are. Gaurav Shaw need not be alone. There are groups with 3 members. So Gaurav Shaw, you can join a group where there are just 3 members. And so some of you might have come in late. So just avoid, don't put any commas anywhere, and write your roll number within parentheses. Okay, so Jasmine and Mayank and maybe some others.
So after everybody is done, we'll freeze it, and one read-only version will circulate to check that it's okay.
Yeah, I think, so Dinesh Karthik is present, seems to be alone. Yeah, so why don't you just do a bit of consolidation? There's some, all right. Dinesh Karthik, you can join some and also put your roll numbers next to your names. Yeah, put your roll numbers. Okay, I think you will be able to complete it soon. There are some isolated names around, floating around. So you can join some other groups.
Enter our names into the list, sir.
Sorry? Dinesh, yeah. All right.
For some reason, we are not able to enter our names into the list.
No, that may be because of this high traffic. It just wait a little bit. It will subside.
No, please.
Yeah.
So do you run a is unique query on this? Unique entries query?
All right. So I think I'll just give you a few more minutes. I think maybe because of the traffic, some of you could be facing problems. So we will give you a few more minutes.
Sir, I think some students are changing others by mistake.
No, that could be because of the traffic. They might be thinking that some cell is empty or, so I don't know. So
I think it's
I think we'll just leave
consistency
it.
issue.
I think we'll just leave it like this. I mean, I think you can work on it and stabilize it. So we'll just leave it here. So we get an approximate idea. There are about how many? 46. About 49 groups, let us say, assuming that these isolated names, Deepti, Bhagoti. I mean, you don't have to stay in a 2-member group. I think you can join some other groups. All right. So you can do a bit of consolidation. You can discuss among yourselves and finalize. So we'll just leave it at this for now. Maybe we'll pick it up later today or tomorrow, something like that. Okay. So you can finalize it yourselves. All right. So now, I am closing this for now. All right. So let us see how we shall proceed with the lab. So visit the page for the virtual lab on logic design. Okay. So why don't you visit the page on virtual lab for logic design? So there's the page. All right. So maybe I'll open it in a new tab. All right. So this is the page. So have all of you opened this page on your own browser?
Yes, sir.
Huh? Yes or no?
Yes.
Okay, good. So first of all, look at this manual for using the simulator. Let's just see. There is a manual for using. I mean, it's not a very comprehensive manual, but still. There are some slides. Let us see what's there. Oh, not there. Sorry. Let's look at this software. Okay, so this one is the main link, software. So there are instructions for both Linux and Windows. Okay. So we of course recommend Linux, and the steps for using this software on Linux are also simpler. But if you need to use Windows for whatever reason, there are instructions for that as well. So can you install this on your system? Just follow these instructions and install this on your system. So let me just see if it works for me. So, so have you been able to open the or start the simulator? Hello?
Yes, sir, it's opening.
All right, so I hope, we will just do some very elementary things now. So let us, so note that over here there are some tools: selection tool, connection tool, clone tool, there's a bus connector, there's a market tool. This allows you to mark areas. So with the selection tool, let us just pick up two gates. Let us say one is this OR gate, and let us say this AND gate. Okay, so we have just picked up two gates. Okay, and as you have seen, we have placed the gates in the work area. All right, so you can also do something similar. Okay, you can also do something similar. So this is a matrix. Now note that you might run into problems with this tool. I mean, it's not a perfectly, I mean, this tool works, but it's not absolutely stable. It might crash at times. So you just be a bit careful. All right, so I have placed two gates. Now I just want to, let us say, I want to check the truth table. All right, so I need to apply inputs, right? So for applying inputs, I can use what is called a bit switch. So I'm putting a bit switch here, and I'm putting a bit switch there. All right. Yeah. This one allows me to move things also. I mean, it's not extremely friendly, but I can move things. All right, so I put two bit switches. So of course I have to connect the bit switches to the gate so that I can apply the input. So I can use the connection tool. All right. So I'm connecting this bit switch there, this bit switch here. All right. So I've given the inputs. I've made some. I've made some connections so that I can give some inputs. Now I also need to see the outputs. So for that there is a bit display, so I can put the bit display somewhere. All right. So I put this bit displays. Again, I need to make connections. So I made some connections. All right. And now I want to check. So of course, now I can change the inputs. If I want to change the input, I can toggle. The bit switches can be toggled. Of course, as you can see, the outputs are not consistent with the inputs. So that's because I got to trigger the the evaluation. So here I have an arrow. So with this, I can simulate. So now, well, both are 1. So if both are 0, let us check again. Both are 0. Both are, one of them is 1, other is 0. So it seems to be okay. All right. So you are familiar with what we call the truth table, right?
Sir,
So,
I have a question. How are you toggling the bit switches?
oh, just double click.
Double click, okay.
Just double click. So, yeah, so let me just write down the. Oh. Yeah, so I'm just writing down the truth tables. So here I have the inputs. So I'm making a table with the inputs. And outputs. So inputs, let us say. So I have X, Y, and outputs I have, say, and so I can have more, right? I can have more. For example, I can have land. So these are some of the combinations. These are the combinations. All right, so this is the only time and is 0, this is the only time or is 0. And is otherwise 0, or is otherwise 1. NAND is just the complement of AND, so whenever it is. Alright. So now you have the table, so you can apply the inputs and check whether they match up or not. So let us just see. So I can simulate. So this seems to be okay. All right. This is okay. So is it okay? Yeah, still okay. So it doesn't change the situation, so that's also okay. And make both of them so I mean this is a very elementary exercise, but still I mean it's a very small experiment, okay? So now say I mean this much could you do? Anyone had a problem this far? Hello?
Sir, my bit display is not changing.
Oh. Are you simulating? You got to click on this simulate.
Okay.
Yeah. So for example, it has not changed. I made both of them 0. It hasn't changed. But I got to click on this simulate, then it changes. So is that okay with you?
Yes, sir. Yes, sir. So every time we change the bit switch, we need to.
Yeah. You got to trigger the simulation. Yeah.
Okay, sir. Yeah, yes, sir. It's okay.
Okay. Then it seems to be okay. So have you got this far? Anyone having a problem? Hello?
No, sir.
I mean, I assume that you're not having a problem, okay? So let us think of another experiment. So you have got two inputs, right? You have got two inputs. Let us say X and Y, all right? So now, how many Boolean functions can you make out of these two inputs? So this is a small exercise that you can do. So you can, of course, we have considered three functions like X and Y, then consider X or, I mean, you can write X and you can write it in many ways, X and Y. So you can write this is X or Y, you can write X or Y. So there are many ways of writing it. All right. So can you write down all the functions that come to your mind? All right. All functions, all possible functions of X and Y that come to your mind. So this can be one exercise. So basically you can, and you can also verify those functions. So first of all, you can try to enumerate all the, possible functions of x and y, and then you can just, I mean, some of those are trivial, so you'll find that some of those functions are really trivial. But the ones that are not that trivial, you can just verify. Of course, now you know that, for example, I mean, one function could be x and y bar, okay? Now you don't have such a gate, right? You don't actually have a gate which does this x and y bar. So let us try to verify this function x and y bar. So first of all, how do we do x and y bar? So what we could do is, you know, x and y, you know how to do. You have an AND gate here, x and y, but here you want to put y bar. So you put an inverter. So, and then you can check the output. So let us just do this exercise. So again, let us write x, y, or we can just try to, let us say x and y bar, okay? So basically we can try to make use of this. So of course, whenever x is 0, you know that the output of AND will be 0. So here x is 0, here x is 0. Now, now whenever y bar is 0, this is going to be 0. So here y bar is 0, but here y bar is 1. X is 1. So, and we expect the table to be like this, right? Are you okay with this truth table? First of all, have you made this truth table?
Yes, sir.
Yes, sir.
All right. So now let us try to verify this truth table. So before we can verify this truth table, again, we need to make this kind of a circuit, right? This kind of a circuit. So let us try to make this kind of a circuit, okay? All right, I think it's a simple circuit, so we can. So we need an AND gate, right? Okay, so let us put an AND gate here. So this one, I think, just a minute. So here I think we can put a label. Let us say X. One second, I'm forgetting how to put a label. Or do I have any place for a label here? CPU. One second. I've forgotten how to put a label. Let me just see. Okay, I'm using this tool after a long time. Let me just see whether there is any provision, whether that has been explained here. No, not much has been said here. Anyway, I seem to have forgotten how to put a label. Circuits and labels. Okay. Oh yeah, there it is. Okay, so under circuits and labels, yeah, okay. There you are. So I can put a label here, X, and I can put another label here as Y. Okay, so.
Sir, are there any shortcuts for selecting the tools?
Selecting the tools, I mean, what kind of selection do you want to say?
Sir, I meant that if when there is any keyboard shortcut for suppose
Oh, no.
selecting connections
No.
or bits.
I must tell you that this is not such a, I mean, it doesn't have a great user interface really. You'll have to bear with its limitations. Yeah, so you can put labels as you have seen. Yeah, labels can be put. So it looks a little different. I don't know. Okay. I don't know. This one seems to stand out a bit. Yeah, it's not absolutely great. I don't know whether this will delete it or not. Let me just try to put the label again. So, there it is. So you have a label there. All right. I mean, so we wanted this kind of a circuit, right? Oh, sorry.
Sir,
Yeah.
so when I'm entering X and I'm pressing enter, it is vanishing.
No. Don't put enter and all. Just click on label.
Okay.
Yeah. It's not a, I mean, absolutely versatile tool. So just you'll have to bear with its limitations. Okay, so.
Sir?
Oh, sorry, not yet. Yes.
Sir, can you please explain how you did labeling part?
Yeah, I'll explain once again, but let's do the circuit, okay? So, yeah, so I am making this tool, this connection. All right, and let's put another bit switch. Not a bit switch, but a bit display. So here I put in a bit display. And here, all right, so let us again try to put some labels. So this one, let us say I want to put X or Y. Okay, this one is an all gate. So yeah, so this is your label X or Y. This one is another label. Yeah, someone had a question. So is it clear? I mean, under circuits and labels, you can just click on that. So you get this label here. So here's X and Y. Or I can just write X, Y. And here I'm putting another label. But this is yet to be checked. X, Y bar. Maybe I can put X, Y bar. Okay. All right. So So this is, these are your, so let us just check, let us just check this one, xy bar. So xy bar is here, right? Xy bar. So if both are 0, it should be 0, okay? Then 0, 1, still 0. 1, 0. And 1, 1. Okay, so this part seems to be okay. So you can take, where did you put this together? So we take all of these. All right, so that's how you can check this Boolean function. So first of all, yeah, so here what we're trying to do. So we are trying to do two things really, or a few things. So let us just see. Things that we are trying to do. Enumerate all the. By the way, should I be using a capital letter here? Yes or no? Hello? Hello?
Hello, students.
Yeah.
Sir,
Should
can you
I-
please repeat?
Yeah, this Boolean, is it correct to spell Boolean with a capital letter? Yes or no?
No,
Huh?
no, sir. No, sir. We generally write it in short letters.
But do you know the origin of the term Boolean?
No, sir.
No, sir.
No, sir.
Sir, there was a scientist, James Boole, from there.
It's very easy nowadays to find out. So let us just see.
Yeah. In fact, there is another custom that if you are too famous, usually proper nouns are capital, but if you are too famous, maybe you can use a small.
Yeah. So yeah. So this one was, I think, George Boole. Let us just see.
George Boole.
Yeah. Okay.
Sir, it is written there in the second paragraph.
It should. Yes, that's it. George Boole. So yeah. So this Boolean algebra is after this gentleman. So that is the reason it is spelled with a capital B. Okay. So okay.
It was used in electronics by Claude Shannon. I think Shannon was the person who first used it in building circuits.
Yeah. So yeah. Okay. So you enumerate all the Boolean functions. That is the first thing. Then second thing is, find a realization of the Boolean function. Okay, so now one thing is that you first find out all the Boolean functions and then find a realization. So we have looked at a few Boolean functions like and, or. Actually, we also saw not. Though it was. I mean, we wrote down NAND first, but there is also not. And then we saw some other, not less, what should I say, less standard function like x and y bar. It is still a function of two variables, but it doesn't have a common name. So now, for some of these, you have standard, realizations. You have gates. You have got an AND gate. You have got an OR gate. You also have a NAND gate. You have a NOT gate. But you don't have a gate for this. But you found that, it is possible to, realize this Boolean function using these available gates. So that's also an interesting aspect, So you might like to ask that, how do you know that a given set of gates is adequate for realizing any Boolean function? So these are, interesting questions, and we'll try to answer those questions in this course as well. I mean, try to find general answers to those questions. But for now, I mean, you find that if you have, these gates, so using the AND and the NOT gate, we could realize this, for example. So yeah, so find it, and then of course there is the last step, that is check the realization. All right, so we checked out a few functions. So I mean, we checked out a few functions. This thing, it's actually this Teams. It is not a. It's actually a borderless window, so it doesn't react. It's a bit problematic. It's difficult to lower it. Okay, so let's cross this out. 1 second. Where is that? Yeah. So we checked out a few functions, right? We checked out a few functions. So why don't you do one thing? Why don't you do this? This is of course the most interesting part. That is, enumerate all Boolean functions. Can you first find out, I mean, how many Boolean functions of 2 variables should be there, do you think?
16.
Yeah, okay. So you can make a table of 16 functions, and among those you can, pick up the non-trivial functions and just check those using this. Okay, so before you check, continue, let us just see. So having done some work, you might like to save your work. So let us see if we can save it. So yeah, it says enter your name. So I can enter my name. And it says enter your roll number. So you can enter your roll number. I'm just entering 999. You can enter your roll number, and then just calling it lab1. So it saves it as a logic file, okay? So it's saving there as a logic file. So let me just see if I can see it here. Yeah, so there it is, lab1.logic. All right. lab1.logic. So let me just check this. Let me start another instance of this. Let me see if the loading works. Well, it seems to have loaded. Yeah. So it has been able to load this. So you can save your work and also load your work. Okay. Yeah. So I think you have seen some basic functionality of this tool. I mean, this tool does have, although it's not that user friendly, but it does have some interesting functionalities. We'll explore those in course of time. But with this little bit of introduction, So what you have seen is that you can also save your work, you can reload your work, and you can use this things to just check out some Boolean functions. So would you like to carry on with this work and check the non-trivial Boolean functions? Yeah. All right. So this is just a very simple introduction to the lab, and I mean this is just a little bit of warm up. You will not be evaluated, or you don't have to submit this particular lab, but please complete this exercise. I mean, why don't you just do it now? And some of you can just show us the list of.
Sir,
Yeah.
sir, could you once again please show how to do the labeling thing?
Oh, labeling. Okay, let us see. So suppose I want to write OR gate next to this. All right. So now under circuits and labels, can you look at this? Are you able to locate this? I hope you are able to see my screen. So can you see this?
Yes, sir.
Under circuits and labels, okay? So I click on label, okay? And I get this. So I bring it here.
Okay.
And then I click it. I go to this label, okay, here. And let us say I want to write OR gate. All right. And then I say label. So it comes here, OR gate.
Okay,
So are
sir.
you able to do this?
Yes, sir. Yes. Thank you.
Yeah. It
Sir, can you show how to copy an entity?
yeah, I'm just seeing whether that can be done.
So we can just press Control and drag. It works like that.
Maybe it does. So it's a little tricky. Yeah, I mean, oh, this one has. It has just moved the whole thing. Okay.
So press Control and move.
No, I can also actually copy it. Just a minute. It's a clone tool. No. One second. What is it? Oh. Yeah, this one is a bit tricky. This one is facility for copy. Clone tool. Okay. So I have been, yeah, this is it's a bit of trial and error. I could do it. So now this is a copy of the circuit. I mean, this whole thing, what I've selected really. So I can simulate this independently. Oh, or maybe I can just. So yeah, so I'm able to simulate this. Okay, so I can. I was able to, just clone the entire design.
Sir, can you please show this step again?
Yeah, this one is a bit. Okay, so let me just. Okay. Okay, first, oh, sorry. So this one, I deleted it. So anyway, I've selected a lot of components. Okay. I clicked on, so let me just see. Okay. I just clicked on Marquee. There's a Marquee tool, and I drew a rectangular box. I drew a rectangle, so everything inside got selected. Now let me see, clone tool. I've clicked on clone tool, so yeah. So what I did was, I just clicked here and quickly moved the mouse. So it's a bit of a sleight of hand, really. But it works, I mean. So using the clone tool, I did it. So using the Marquee tool, I marked a part. Of course, that's not essential. So using this Marquee tool, I can mark some part and I can delete it also. So let me see if I can repeat the performance. So here I've selected everything. I've done a clone. Yeah, so it is reproducible. It is yeah, it's not so difficult. It can be done.
So I think with simple selection tool also we can select and clone.
Yeah, I mean, okay. Yeah, this is not the only way to do it, but yeah. This is not the only way to do it, but it can be done this way. With selection also, it works actually. Yeah. Okay. So this is, so now you can just, I think today's, I mean, the lab for today is just to, introduce you to this tool, and you can just play with it a little bit. Yeah.
So CRM, maybe we can stop at 4 for today, and I mean.
Yeah, we'll be stopping now. So all I'm saying is that now that you have this tool, just, I mean, we have given you this exercise. I mean, this is a very simple exercise, really. So just so that you have something that you can, on which you can apply this tool. Okay. So yeah, Pavitra, so you might like to say something, and then we can.
No. I don't want to say something. I mean, I don't want to overweight them.
No.
Sir, I just want to confirm that we don't need to submit anything this time.
No. This today's lab, you don't have to submit anything for today's lab. Today's lab, we wanted to first of all. Okay, maybe we can just open that group. So let's see if they have.
Or CRM, that we can do later. What I'm suggesting is that if they have any question, they can ask us and discuss with us.
Yeah.
Group, maybe we can do later.
Okay,
I'm
just opening it. That's
Sir, can we zoom or something on the simulator?
Yeah, zooming is there. I mean, it's not a. As I told you, it's not a tool with a great interface, but you can.
So this tool has been developed at IIT Kharagpur itself. Professor CRM and his students have developed.
Yeah, so you can zoom, but what is missing is a scroll bar. I mean, we don't have a scroll bar. Actually, this framework which you see, this is this framework. It was in the public domain. I don't know. They might have withdrawn it by now. So I mean, we use this framework because you have some the drawers and all that, but unfortunately, it's also a difficult framework to use. I mean, especially to program more than use. It's not particularly friendly to use either. But anyway, that's how it happened.
So maybe if the students can report bugs and other things, they can contribute to the development also.
We have a different plan. So there is not much point in reporting bugs and all that. just use this tool to the best of your ability. I mean, in the future, we might have a different, version of this tool which can be used in the browser itself, but that's not happening right now. So right now, you can just use the tool as it is available. Yeah. I was just looking at the groups that, so they have, okay, this is what they have now. So they have 48 groups. Yeah. There are 48 groups, and I think with mostly
Sir,
four
can you tell
members.
us the significance of groups here?
Yeah, the significance of groups is that you'll be, doing the experiment together. We expect you to divide the work and basically submit.
There will be only one submission.
One submission per group, essentially. One submission per group. So, yeah. And regarding tests in the lab, I think so. We will have an emphasis on the assignments, but we'll also have a test. So, does the over here, have we mentioned anything about tests? We have not mentioned anything about tests here, but yeah, we will have at least one test in the lab. Okay. I mean, some kind of test we'll have, at least one test we'll have in the lab.
The test will be individual, right?
Yeah, tests will be individual. Yeah. All right. So that's the. All right. So basically, that's all for now. Anything else for us?
No, I think if they have any question, they can ask.
Yeah. Do you have further questions? Well, if you don't have further questions, so I'll just tell you what I told you before. That is, just complete today's assignment. And one good thing is that, so you can, now you might like to know how you will share the work. So this tool has one useful feature which we have not demonstrated today. We'll be demonstrating. That is, you can modularize the circuit. So suppose you have drawn a circuit like this. Developed a circuit like this. So suppose you want to use the circuit 3-4 times. So or if you have you can divide the work into various components and develop a circuit for each component, and then you can and save that component as what you call a module or a sub-circuit. Just as you write a function when you a big programming task, you might be able to break up into functions. So similarly, a big circuit development task, you can break up into the development of smaller circuits. So each member of the group can focus on the development of a part of the circuit, and then you can just put those together and get them working. All right. So you this is you do need to do you do need a bit of planning so that you can have a overall design, and you can split the design so that each member has something to work on, and then you have a way to combine the parts and have a overall working experiment. So So you can have you can put the groups or the members of the groups have ample scope of working together to make the experiment successful, okay, while you use this tool. So I think with with this introduction, we can stop here, and you can familiarize yourself with the tool a little more.